All right, guys, so it's going to be a very short, sweet formula sheet. All right. So we have like probability of A or B. What's that? What's or basically mean? Who? Or means add. Because the or bouncer, is the or bouncer the nice bouncer or the mean bouncer?
He's the nice bouncer.
There you go. You had a 50-50 shot. The or bouncer says, you give me any of these requirements and I'll let you in. So the or one lets more and more and more people in. That's why it makes sense that it's addition. Maybe? Well, why do I not just stop here?
Minus A and B.
Yeah, because if I add everything in A to everything in B, there might have been some that were in both. So they would have been double counted. Debit counted. Coolness. And then we have probably A given B. Let's
A and B addition on the top. I mean multiplication on the top. Yes, it's P, A, and B.
beautiful. So no multiplication, just P, A, and B. Divided by
P, B.
P, B. I like it. And then the formula, one last one, that actually came from this one. What's the formula for this, Dewey?
Times.
Yeah, so it's like the probability of one of them times the probability of the other one, given that that happened, right? Just like, when do I use this? When I pick something out of, when I pick two things out of a hat or something. If I don't put the first one back in, it's going to affect the probability of the next one. We know that. 4 out of 52 kings, and if I throw a king away, 3 out of 51, and so forth. We've done those kind of problems before. There's another way to write this same thing. Those are both the same because and doesn't matter which order they're in. So both of those come out to be the same thing. Okay, we're going to look at some homework problems. If I don't get questions about them, because you should have questions about them. That's really all the new stuff from the probability chapter, right? Okay, I like it. Anything else you want to suggest should be on there? I'm always surprised nobody says, an example problem? Notes? No, you already know I'm going to say no to that, so. Okay, I like it. Maybe. Okay, so before I do my homework question, do you guys have any homework questions? And also I have the answer key for that practice double quiz I gave out. I don't know if I brought any blank copies of that. Probably not. What you got?
Can you go over C on number 42, please?
Oh, okay. So we got this stuff written down? You should already have this stuff in the notes, to be honest, but just to be clear, this is all the stuff you can have. Only this stuff when you formula sheet. Oh, beautiful. 42 is this one. This is, I think I warned you guys about this. Don't gloss over the first. Oh, that's freaking me out. I'm like, I don't exist. That's right, sorry. You're all having a hallucination. It's me. So 42. It's the very first thing it tells you is that U and V are mutually exclusive. Before I go read any other shit, what can I immediately write down? U and V are mutually exclusive.
0 and 0.
Who to what?
Write down the probability of 0 for U and V.
There you go. Because to be mutually exclusive means if one of them happens, the other one cannot. If I'm holding a rock, what's probably I'm holding ice cream? Well, 0. I got a rock. I don't have ice cream. Yeah. Again, it used to be a cat and a dog, but oh shit. All right, but do you see? Maybe some of you guys did exactly what I'm gonna say. People gloss over that first sentence, like, okay, you asked me a question, but that right there is important information. And then they tell me also, so I know these 3 things. So what is the formula for probability of U and V? Huh? Oh, actually, not the formula, but we already wrote it down. Sorry, I'm thinking ahead. So U and V is 0. I like it. I think the question was on part C. That's what I want. So you can figure out part B on your own. U or V. That's one thing. What's the formula for that?
Probability of A plus probability of B minus probability of C.
So what's it for this one? Probability of U plus probability of V minus U and V. But of course we know U and V is, that probability is 0, and I know what this is, and I know what this is. Is that cool? So if you skip that first sentence and you don't write this for yourself, you are going to just die on this problem, because that is very useful information. Okay, maybe. That also happens like in number 41 and number 40. You know, like, yeah, Jeff. All right. So, like 41, what's it mean for 2 things to be independent? If A and B are independent, what do we know? Oh shit! How do we check to see if 2 things are independent?
It's 42. 1842.
Say again? Sorry.
42.
I'm looking at 41.
Yeah.
Yeah, 41, they say J and K are independent. So I'm just doing it in general. If I tell you any 2 events are independent, like A and B, what does that mean is true? You can look through your notes. What's the test to see if 2 things are independent? What must be true?
P of J must equal P of K.
Let's just talk about the A and B. No, that's not true, though. Again, I always so desperately hope that you see this is not mathematical. If A and B are independent, they do not give a shit about each other. B happens. Does A care? Nope. It stays the same. I mean, that's it. That's it. That is the idea. B happens, right? Given that B happened, does A care? No. If this stays the same, they're independent. Because A doesn't care that B happens. It's like, that's nice for you. I'm going to do what I was going to do anyway. Baby? If that changes, if B happening changes the probability of A, these are not equal to each other, then of course we call that dependent. Baby. Yes.
So would that mean that the probability of J would be 0.3?
Yeah, because again, what can you write down from the first statement? If J and K are independent, then the probability of J equals the probability of J given K, right? Look in the other one. And then that's an easy ass problem, right? And if you just skip that first sentence and you're desperately trying to figure out what's the formula to figure this out, nope, it's an idea in that first sentence. So, if events A and B are independent, and I know that probability of A given B is 0.7. What's the probability of A? 0.7. Because if they're independent, B happening did not change what A was, therefore that is what A was. Bam. So I feel bad for the students to just skip that first sentence. They're like, okay, that's words. Where's the work? Oh, there's the work. Where's the formula? Let me throw this shit in. No formula's going to save you there. Yeah.
Okay, can you explain 40 then?
40 is just like 42.
So it equals 0?
No? Well, you got to show me why. What's the formula for probability of E given F? That's the number 40, right? What's the general formula for E given F?
P and B over.
Do it again, sorry.
P and B over.
No. There's no B's in it.
P. P of E.
P of E and F.
Given.
Right, the top is and. Good. Divided by the given. We know the bottom becomes the given. We've done that a lot of times. Or a decent amount of times. Do I know P of F in 40? Yes. Do I know P of E and F? Yes, because they just told me they're mutually exclusive. So this is 0. So I need to see that work. But you see, here's the key on this problem. If they ask me a question that's got a formula associated with it, yeah, I'm going to write that down. And then I'll step back and say, do I have everything I need to plug in to get their answer? If you skip that first sentence, you won't. Yes?
So with 40, so I actually got it down. But with 43, you do the same as like 41, right?
43?
Yeah, same 41.
Yeah, so this was neat. All right. I don't want to do every problem in this section.
I just couldn't get it. I mean, I did it.
Now, this is a neat problem because is there a formula for this? No. But did they tell me something that has a formula associated with it?
Yeah.
Yes. Right? So you write the formula for this, and then you see if they told you enough information to figure out what they want. So often in mathematics, it's either the question, I write the formula for it, or it's something they told me I write the formula for it, because maybe it's got what they're asking me for in it. And then it's some algebra. So what's the formula for probably Q and R? There's two ways you can write it. What's the formula for probability of Q and R? There's two ways you can write it. So remember, probability of A and B is probability of A. That's probability of B given A. Probability of B times probability of A given B. So you can do it either way. It's sort of like if I said, you and you come with me, and you're like, him first? I don't give a shit. Who comes first, right? So that's why there's two different ways to do this and, because it doesn't matter what order they're really in. So what's the formula for this? What's one way to write the formula for this? I don't have A and B. So how do I write this formula?
Probability of Q.
Probability of Q times
Probability of Q given R.
No?
Or probability of R.
R given Q.
Exactly. So see how fundamentally it's a multiplication of the two? But the second one is given that the first one happened, of course. Given that Q happened. Why? Because it just freaking happened. You multiply by the probability of R, given that was true. Do I know the probability of Q?
Yeah.
Yes. Do I know the probability of R given Q? Yeah, you do, believe it or not. The very first sentence, Q and R are independent events. So this is all I'm going to do for this problem. If you write down what that means, you'll see what to do with this. If Q and R are independent, what's the probability of R given Q?
0.4.
Don't tell me numbers, tell me idea. If Q and R are independent, what's the probability of R given Q? Probability of R, not Q. So again, I love you guys. You're trying to memorize shit when you really, and I understand, you're used to memorizing a lot of shit, but you gotta get the concept down. If R and Q are independent, does R care that Q happened? No, so it's gonna stay the same as it was before. And do you see how now you've got, you know this, right? And you have what you're trying to solve for right there. Algebra, bam. But that first sentence in all of those problems, 40 through 43, that first sentence has something you can write down immediately so that the rest of the problem is easy. Without that, the rest of the problem is impossible. Right? Maybe? Oh man, you guys are like, what am I doing in this class? Yes?
So how do we solve it?
Well now you just, okay.
Just replace it.
Yeah, so again, Since R and Q are independent, how can I rewrite this? Since they are independent, given that Q happened, does the probability of R change? No. So this is the same as what the probability of R was before. Do you know this? Yes. Do you know this? Yes. Do you know this? No. Algebra. You got a piece you don't know, you can solve for it. There's a reason for algebra. There's a place for algebra. Okay. Sorry, I won't sing again. You don't deserve that. Yes. I am too, so you can. Sure. No, you must see my YouTube. I'm gonna monetize my no. 30-minute ad I can't skip. Screw this shit. All right, sorry. Yes.
I had a question in regards to the quiz. If I could ask
Sure.
that.
Yeah.
So on the bottom, like number 4, when you're talking about if A and B can be independent or mutually exclusive,
Yes.
what's a good calling factor to figure those out? Is it with the given or?
All right. What's it mean for A and B to be independent? In order for them to be independent, what must happen?
They can't affect each other?
True. So what's that mean mathematically? If A and B are independent, what's that mean about the probability of attack me? The probability of A given B, for example.
It's probably
B bam. B happened. Did A give a shit? No. It's the same as what it was. B happening does not change what A was. That is the idea. So that, of course, is how I write it mathematically. What about this? Become a B.
probability of B.
There you go. Why? Because if they're independent, A happening doesn't change B. Now this question is easy. Where to go? Which question was it again? You were asking about the quiz. That's right. So it says again.
It was
Oh
just
yeah.
the difference between like independent and mutually exclusive. And how
So
to
no.
figure
So
that
don't look at part A. Is that part of what you're looking at?
out. Yeah.
Okay. How can I answer part A? Do I have numbers for either one of these situations? Are they equal?
No.
So are they independent then? Nope. In order to be independent, these must be true. I can see they're not independent. Yes.
For the quiz, how much of the, like, is it all of chapter 3 and then is it chapter 4 as well? Or
No.
It's all chapter
Well, wait. All right. My brain is still in the other book sometimes. It's probability. And this book is chapter 3,
Okay.
right? Yes. We haven't even started lecturing on 4 yet. We're going to do that today. I
So
like it.
we won't be testing what we learned today.
I don't know if you picked up on this yet, but we only had one quiz. I'll never quiz you on something that we learned the class before that. You guys kind of with me? I try to make my quizzes based on the homework that's due that day, which means we would have finished talking about it a week ahead of time, like 2 classes back. So we're going to get into chapter 4 today. That would suck for me to give you a quiz on it next time because you wouldn't have had time to do the homework and ask questions. I like it. Yes.
So it's like 0.1 divided by 0.4,
That's what it eventually comes out to be.
but it equals 0.25, and
Beautiful.
that's not independent because it does not equal 0.4.
No. All right. All right. If 2 things are independent, what has to equal each other? The probability of the given must equal what it was before. You're comparing no givens. You're comparing probability of R with probability of Q. Ain't no reason they should be connected. When you're talking about independence, you have to look at something that involves how they interact. That's the only formula we have about how they interact, a given. So you can't compare probability of R with probability of Q and figure out if they're independent or not, because there's nothing you did that shows how they interact. So do you know what the probability of R given Q is? No. Right? I don't see that up there at all. So I have no idea what the probability of R is going to be. Okay, maybe? No? So it doesn't... Let me think. How do I say it? R and Q are independent, which means the probability of R given Q would equal to the probability of R. Because if Q happens, would R care? No. This doesn't say any of what I just said. There's no reason that this should equal that. None. Yes?
So if 40 were, they would, because if it's given.
Yeah, we're told that they're independent. So I know J given K equals J. That's why that one is no work at all. It's just a conceptual. I like the way it said conceptual. Transylvania. Sorry, Little Rocky Horror. All right, maybe. Sort of. Oh, you guys are like, I get about 10% of your references. All right, that's fine. Okay, this one actually, as long as I have this up here, I want to look at this real quick. There's two problems sort of like this. This is perfect. What the mistake people make is they just go, oh, words. Where's the problem? There's the problems. Let me figure out, is there a formula for this? Ain't no formula for this. Plus, there is a formula for this, but if you'd read the thing, you would see they tell you what this thing is. So what does C mean? Preferring life in prison over the death penalty, right? Lock me in a room, don't kill me. Right? And they tell me that in the write-up. So you got to read a little bit. Right? And they tell me this one just directly. Latino Californians. What percentage of Californians are Latino? They tell you. They even tell you this one. In fact, how many percentages do they give me in this setup? 3. So the first 3 questions are just those. There's no work. So can you see, what does this one mean? Given that they are Latino, right? Given Latino, the probability that they are Californians who want to be locked up instead of killed, right? Right? Isn't that what this is? These are the people that want to be locked up, not killed, given that they're Latino. So look what it says. I kind of have it off the edge. That word given doesn't always show up. Look at that sentence right here. Among Latino California voters. So what kind of person am I talking about? Latino California voters, right? So given Latino, given L, 55% prefer lockup over death. Prefer lockup over death. Bam! That is 55%, 0.55. Maybe. Sorry, if you're sick at home watching Price is Right. Here you go. All right. That's sorry. Memories of me as a little kid watching Price is Right when I was sick. All right. So your first, in this kind of problem, your first task is to identify each probability they give with the symbol. Why? Because then when you hit this problem, you write its formula down, and you can just plug shit in. So that's why they're being really nice with these first 3 questions, saying, hey, that's what you got to do to be able to answer this question. What's the formula for this? There's 2 ways. You can write for L and C.
P of L equals P.
P of L and C. What's that?
P of L equals P.
P of L and C equals?
P of L times.
Yes, good. So P of L and C equals P of L times?
P of C given.
Will I know this by the time I get to number 48? Yes, number 45. Will I know this? Yes, number 46. And I got those because they told me those, right? Do you guys see what I'm saying? Write the formula for what they ask you and then go see what you know. I know both of these things. Ah, sweet, this is easy. Just throw them in and multiply them. Bam. Man. So just like in an algebra problem, they tell you a bunch of numbers, you identify what the numbers mean so you can put them in the right place in the formula. Okay. All right. There's another problem like this with even a little bit more information that'll be even more fun. Right? Yes?
Are you able to go over one more?
Yes?
I know you went over independent variables, but could you talk about 50?
Oh. You will know that already. What do I mean? If L and C are independent, what has to be equal to each other? If L and C are independent.
Probability of L, probability of C.
No.
Probability of L given C equals probability of L.
Beautiful. The probability of... So if two things are independent, right? If L and C are independent, that means the probability of L will always stay the same no matter if I know C or not. Does that make sense for the word independent? That means the probability of L will stay the same even if it's the probability of L given C. They will equal each other. Don't you have those two things? Oh, I'm sorry. These two things now, if you look at it the other way around. Probability C and probability C given L. If I look at it the other way around, what should be true if those are independent? The probability C and the probability C given L should be the same. So you'll have answers here. You can just compare the numbers. Yes?
So even if it's opposite and it's true for the opposite, it'll...
Yeah. If two things are independent, he doesn't care if he happens and he doesn't care if he happens. So it doesn't matter which way. Why am I going to do it a certain way? Because there's only one way that I know both of the things. Yes? Yes.
And you're plugging in the numbers, are they supposed to equal 0
No. I'm not sure what you mean. The only thing I know, so if I told you that events F and W are mutually exclusive, what can I write down immediately? Probability of what? F.
Given.
F and there it is. W equals 0. And then anywhere that shows up in any equation that they asked me for, I put a 0 there. So I want to be really careful about your question and what it meant. So if I ask you what's the probability of F given W, does it even matter that I don't know this? What's on the top? Yep. And what is that in this case? 0. So it doesn't matter what this is. As long as it's not 0, you're fine. This will be 0 over who cares equals 0. That's just like that earlier problem we had, right? So if I tell you two things are mutually exclusive, you write that down. If I ask you, are these two things mutually exclusive, you calculate this and see if it's 0. Works both ways. Okay. We move beyond that. Anything else from the probability stuff from the quiz? Let me give you the answer key for that. I want to give you a break in my handwriting so I can type this up. Extra copies of the... Oh, the practice quiz. Yes, I should. If not, I can just print them out. It's crazy. Oh man, I lost count. Let's see what happens. questions about probability? Let me give you a chance to look at that key real quick. Again, if you didn't try the practice quiz, don't look at that thing. Right? It ain't for you. You don't have to do the practice quiz, which means you should never look at that if you don't.
Go to the office. How did that?
What you got?
Just the same stuff as the beginning.
So what?
Like 43 and 40. Like I did it. Like the tutor said I got the answer, but I don't understand.
So it's.
I just don't get it.
So here's something interesting. Let me show you. Right? That's generally true. That will always be true. That equation is true. That's why I say that and is basically multiply. This one has to be adjusted given that he happened. But if I do a problem like I replace the card back in, do the probabilities change? If I pick a card and then put it back in. Let me try this again. If I pick a card and then put it back in, that's with replacement. I'm resetting everything. So all the probabilities stay the same. Right? And we've done problems like that where this probability doesn't change. The bottom does nothing changes because I put the card back in. Okay, I like it. So if I also knew that A and B are independent, what piece of this problem, what piece of this equation can I change a little bit? If A and B are independent, what is this? Probability of B. I love it. Because A happens, if I know this, I know that B doesn't give a shit. So if this is true, then the probability of A and B equals probability of A times probability of B. That's the only time you can just straight up multiply two probabilities to get the end is if I know they're independent. So if you write the formula for probability of Q and R, probability of Q times probability of R given Q, and then rewrite it like this, you can just plug shit in and solve. Because they tell me they're independent. So what's probability of Q and R?